well-architected applications. If this is your first time, this is a live coding series where we are implementing lots of cool reference implementations, examples, anything you guys might like. And today is all about automating security and making the security part of well-architected apps. And if there is anything in this aspect that you would like me to approach today, please feel free to comment on the chat. This is really not me giving a talk or anything like this. It's just interacting with you guys. Let me know what you want to see done and what you would like to see on this channel or even in this talk today. So last week we started implementing well-architected framework. If you're not familiar with the well-architected framework, let me just get back and show you guys this document. So this is the document that describes the framework. It's available on the white paper section of the website, and here you can see that it divides a well-architected application in 5 pillars: security, reliability, performance efficiency, cost optimization, and operational excellence. We started with the security pillar, and in this series we're going to go through all of them and implement their best practices and making sure that your app is not only ready for the cloud, but leveraging the best that we can offer in these 5 areas. So I hope this makes sense to everyone. Okay, and of course, this is not done equally on every customer. So the framework is a bit abstract. It does not provide implementation. So this is what we are here for. So it provides some general design principles such as stop guessing capacity, or test systems at production scale, or automating to make architectural experimentation and things like this. But the really core of the framework is with the questions, the questions that you guys are going to find. For example, in security, we start with security 1. This is the first question of the framework, saying how are you protecting access and use of the root account credentials. So this is a very important part of AWS. And when you create a brand new account, and I created a brand new account here for us to experiment. So this is the console on an account that has never been used at all. And I'd like to go through the steps to make your account secure in the first place. So after creating an AWS account, like this one is totally brand new, I just created it before the webcast, you can go to IAM, that's the identity and access management part. And here you will see we have a few checkpoints that we may want to do. I will do those in code and we can implement a lot of that. I will just do it this time manually, so you get a good understanding of what you should be doing. So deleting your root access key is important and done by you automatically. So you should not use root access keys to do anything at all, because the root account, this one that we are in right now, because we don't have any others, this is the first one that was created to us. This cannot be restricted in any way. This must be open, because this guy can really do anything. So we need, in order to be safer, we need to create more restricted credentials that can use the least access principle and allows only the required things to be done. So this changes a bit environment to environment. So I'm going to do the most straightforward thing first, and then we can dive deeper on this. So the first thing I would recommend everybody to do is creating a group. So this group will be my admins group. So I will create and give this group a policy, such as a power user policy, that allows this guy to do whatever he needs to do on AWS. You could use other policies. This is just a sample one, and we can see what it looks like. I mean, get to this power user policy and add it to the group. And here we can see how this policy look like. So this policy is stating that all actions on all resources are allowed except for these IAM and these organizations. Those are not really allowed. So the power user policy will allow you to do anything on AWS except creating additional users and organizations. So except for describing organizations, this might be important. So this is also allowed, but just read only. And once you have a group, we can create a user inside this group, and adding a user is just as simple. So I will create, for example, the admin user and allow him to have console access, for example, and access keys. I will use both credentials today. And let's set a password for this guy. And let's say it is, well, I will hide this from you guys from just a sec, because this is an admin user that can do anything. So let me just add a safe password here. So that is done. And if he must or not add the password, change the password, and then I will grant him power user, add him to this admin group, and by now he should be able to do whatever he would like. So again, I will copy this to this access keys and credentials to a separate text file, and we can move on with automating some things. So this is just to show you guys how to complete the initial checklist for IAM. For more experienced users, we are going to get a lot deeper on this. I'm just showing like the really basics of security, so everybody understands that it all starts with the very basic actions and how to do them on a brand new account. So let me just copy those access key, the secret key, and close, and we are done. So by now we have a admin user with an admin key that has never logged in, and in the dashboard we can see that we have the IAM user and the group checklists created. So we are halfway to a better account in terms of security. On activate MFA on your root account, this can be any MFA software that you guys would like. In here, it can be a virtual MFA, like an application or something like this, or a hardware MFA device. You can use your favorite software or your favorite device manufacturer, such as Gemalto, do this one-time password things. And I will show you how to set up Authy. So this is Authy, A-U-T-H-Y. And this allows me to set my computer and create those keys. So I will create, my phone is in Spain and it is quite public by now. This is my email. hermanj@amazon.com at your service, and I will try to receive an SMS. So also he does this so we can recover this account later. And I got it. I got the message on my phone. Let me check this, and it is 854-805, and we got an MFA device. So this is all it takes. Now I'm gonna add a new account. So this account, add authenticator account. Oh, this is it. I don't have a master password. Let me set one. So this should be it. And we can work with this. Let's see, devices, multi-device. Where can I add the thing? Oh, okay. So let's proceed with creating a virtual device, and I'll create the app. And here you can see the key, the secret configuration key. And I believe we just need to paste this into Opti, and we can select Amazon Web Services. This is AWS well architected on Twitch, and done. Now when you click it, when we select this, we can get a token for this one, I hope. Where can I get the token? This is a new version of this, I'm sorry, but this should be all it takes. Weird. Well, I'll have to check this, and perhaps it's on another window. Oh, here it is. So you just have to copy one number, and here. Well, I can surely improve this. I got a Yeti microphone, so this is a best one. This is a very good one, my friend. I hope that it gets better. Let me get this up a little bit. So I hope audio is better now. I'll try to speak more loudly and clear. And we have another token. So we pasted, we need to paste 2 successive tokens. So in 19 seconds, we can get another one. And thanks, by the way, if there is anything wrong with the transmission, I would love to correct them as we go. I'm moving it to a better place. Let me try lowering the volume then. I hope this is better right now. So this is it now. Better. Let me get the token before it expires and activate our virtual MFA. Okay. Thanks. Awesome. Thanks, guys. I hope this is comfortable for everyone, because we're going to go for a long while here, and surely this matters. Okay? Perfect. I tend to get a bit louder as we go, so please, again, let me know if it goes out of hand. So now we have MFA set up for our root account, and if we try to log in anytime with the root account, we need to enter this code and make sure that everything is all right. Okay, and then the last step would be to apply an IAM policy, and managing the password policy is quite simple. And the hard part is determining what you want here. There's people that prefer longer passwords. That's makes more sense, I guess, but you know, this is different for everyone. For my account, let's say that I want to require at least 10 characters on my password. So now we have this dashboard with 5 out of 5 complete. Okay, I highly recommend everyone doing this 5 steps and making sure you have this 5 security checkpoints check. It's a great start to securing your account. And another good one is to customize this link. So you, instead of your account ID, you can use a better number, a better name. So let's say, for example, well architected, or something like this. Let's on Twitch. This probably doesn't exist yet. On Twitch, looks good. I will copy this link, open a new private browser session, and let's see if it works. Oops, not this. I copy the whole thing. Doesn't work by some reason. Let's get it all copied, and now it's probably going to work. So now we are within the well architected on Twitch account, and I can go in with that admin username and that user password, and now I'm logging in as a regular user. So this is the first thing that I wanted to show you guys how to do. Okay, so far everything's all right. Now let's move on to automating and coding, and let's get to code and Lambda functions and more in-depth automations. I would just like to check the volume is all right. Can you hear me? Okay, so about storing private keys, encryption, and storage, my dear criminal-minded, I would say KMS is the way to go. So we have a service called Key Management Service, or KMS. I don't know where. Let's see. That would be the thing to look for. So AWS KMS. There are a couple options here. KMS is the service for managing keys that are used within AWS. So if your keys are to be used to encrypt ABS volumes and things like this. Oh, thanks for that. It moved behind IAM recently. So KMS is for encrypting RDS databases, EBS volumes, all that's within AWS is pretty tightly integrated with KMS, but that may be, and that's very price effective, but in some cases, you may have hardware devices for key management yourself, and you may need to integrate using the same mechanisms. So we also have AWS Cloud HSM, and Cloud HSM are dedicated hardwares. So this is like SafeNet Lunas, like the real the appliances for keys that you would have on your infrastructure, for example, and you can get those inside AWS with Cloud HSM. But this is a bit this is a dedicated hardware device on the cloud for you, and KMS is just a key management service that will be better, more tightly integrated with the rest of AWS. And we are going to work more and more with this, and we are going to get to credentials pretty soon and security keys. I would just like to say that our idea, the main thing about this sessions, is to use the console less and less. We are going to try to automate everything. So as we go along, we're going to use more and more of the CLI and CloudFormation and code to perform all actions and try to do it less with the console. And towards that, an essential tool is CloudFormation. So we'll start to code everything as in our infrastructure as code, as CloudFormation code. So just if you don't know yet CloudFormation, so this is the service page on AWS CloudFormation. And the idea is that you can create templates of your architecture and everything within AWS. So you don't need to create everything by hand, and you can make sure everything is created correctly, atomically, and things like this. So let us pick some simple templates just to show you guys what I'm talking about. So instead of going through the console and creating everything by hand, say for example in a EC2 instance, we can declare everything in this JSON template. So this is a viewer for JSON. If we see this is the raw data, this is just a bit easier to see. And a CloudFormation template contains this usually just 5, sometimes 6 ports, and the important part is resources. So this is the most important thing, because this is where the things you're going to create are declared. So this template creates an EC2 instance and an instance security group. So the firewall around your instance, the security group, is declared here. And those things reference each other, and they are composed of a type and properties. And the type defines what the CloudFormation is going to create under this name. So let's check on the CloudFormation reference what this type means. So if we go on EC2 instance on the CloudFormation docs, you can see the same things you would see when starting an instance. So for example, the availability zone, the image ID, everything. So there is everything that you can declare is here. And Zoomage CloudFormation really does not support all the services, but let me show you something that may help. There are some special CloudFormation elements, if you see here, and one of them is called a custom resource. So here on CloudFormation custom resource is your way to extend CloudFormation to do anything it already does. It does not. For example, if you would like it to perform any action, for example, database migration, or create something that's not supported yet, anything at all, you can extend CloudFormation to call a custom resource for you. And there are 2 ways around that. You could do it on using messages, but really what you want here is to call a Lambda function, and it's just going to call your Lambda function and run your code on your behalf. So if you could use this resource to create other AWS services or services even from other providers that are not supported. So this may help with that. I know it's not ideal. We try to get all AWS resources natively on CloudFormation, but it is a workaround that. And there are some other interesting things. For example, if you see this AWS CloudFormation stack element, this means that you can have a CloudFormation stack within a CloudFormation stack within a CloudFormation stack, for example, and turtles all the way down. You can, if you have, for example, your application architecture is composed of many tiers. For example, you have compute tier, web tier, message processing tier, data tier, caching tier, and whatever tiers your app has. If they are developed by different people, for example, or you don't want to get a huge CloudFormation template, you can compose CloudFormation stacks with this, inner stacks, let's say like this. So that's one way to compose. So you can compose and extend CloudFormation as your software needs, and this is an important capability that we are going to explore a lot in these sessions. Okay, and so the first thing I want to do here is cover this Sec1 questions. How are we protecting access and use of the AWS root account credentials? So what I've done is encoding this in a CloudFormation template, and it is all open source. So I'm going to show you guys some code, and it's all available on my GitHub. I will paste you guys the link. And GitHub, Fireman. And this is the repo. So I just pasted on the chat window the repo with all this code that I'm going to show you today and on future episodes. And let's see this no root template. So I created this as an automation, so we can check out like how we can automate our security verification. So what I'm going to do is I will create a log filter on CloudTrail. So I will try to get all my logs in CloudWatch logs, and I will listen on my CloudWatch logs for anything that matches this expression that would be using the root credentials. So if any API call or anything actually uses the code, any API call that is made under root, I want this to trigger, this is an error. So we are going to treat everything as an error. If the root makes any account, we should notify SNS topic. Here I'm referencing it as a cause of error topic. And from SNS, you could take any actions. So SNS can send emails, can call HTTP endpoints, can call Lambda functions. So whatever your error handling process is, you can automate it from SNS. I hope that does make sense. So try to let's build a picture of this in our heads. So the first service we're going to use is CloudTrail. So if you don't know CloudTrail yet, CloudTrail is this service, and it will log everything that happens in your account, and it will ship those logs to CloudWatch logs. So we are going to listen for every activity that happens, and when they match the expression that is filtering for root activity, it's going to call my Lambda function, and my Lambda function is going to publish a message So let me show you guys the code for this Lambda function. It's in the same repo. It's quite simple. I hope you don't mind, it's JavaScript. So I will get the environment variable with the topic name and get the event that triggered that as a JSON and add that to a message and ship it to SNS. And this is pretty much it. But instead of declaring everything in a single CloudFormation file, I decompose this in a couple different components. So it would be easier to understand and to copy and replicate parts of this in your own infrastructure. So let me open a new window with this code here for you guys. Let's work on a real code editor because the browser would just give us headaches. So it's on here. So this is the same code just in my local machine, and to build this trail, so to build this this policy, no root YAML, we need two things. We need a subscription to CloudWatch logs, and we need somewhere to put our Lambda functions because they need to live in AWS. They're going to be published to an S3 bucket and not living on my machine. So this is I separated this other template. So this is the template with the audit trail with the CloudWatch logs part. So we're going to go through it all, and let's just go to some simpler templates first, because for both of these to work, we need a code bucket. So this would be just a simple S3 bucket to store the code for our Lambda functions. And this would be the cause of error topic. So if anything happens to our, we consider an error and we want to notify the administrators, send an information to any system, or anything like this will be triggered to this topic. So I hope this is clear to everyone by now. Let me just repeat this one more time so you get the flow. Everything that happens within your account on AWS is perceived by CloudTrail and logged. This log can be a S3 bucket or CloudWatch logs. Here we are going to use CloudWatch logs because we can subscribe to those logs and take action, such as sending those logs to SNS or doing anything we want, triggering our cause of error process. All right. This is YAML. So this is actually Atom. I'm using Atom as a code editor, and this is the YAML template. So you can write CloudFormation templates in JSON or YAML, and this is just plain YAML editor, nothing specific for CloudFormation here. Okay. And so let's create those first resources. Then let's do it by hand first, and then we can automate it. So I have this code bucket, and this is just a very simple S3 bucket, the simplest template you could have. But there is one thing. How can other templates that are not within this one or composed of this one, how can they reference one another? And there is this trick called exports from CloudFormation. So I can get the name of this code bucket. So this function ref will get me the name of this bucket. And how do I know that ref gives me the name of the bucket? Again, the answer is always on the resource type documentation. If we look here on S3 bucket, we have all the properties that you can set on an S3 bucket. And on return values, we can see that when you call ref is a CloudFormation function, it will return the logical ID or the resource name for that attribute. You could also get the Amazon resource name or other properties, but here we are taking this reference to this code bucket and exporting under the name code bucket. So everywhere else that we need, such as in our code or anywhere else, we can reference that. Another example, our cause of error SNS topic. I create a reference for this cause of error topic named COE topic. And in other templates, such as this no root YAML, I have a import value COE topic. So you can see that this is called cross-stack references. If anybody would like to look that up, this is cross-stack CloudFormation. So this is using this export and import value, you can reference and decompose your stacks even further. So one interesting aspect to understand is when should you use import and export, when you should use like this cross-stack references, and when you should use the CloudFormation stack, the composition that I just mentioned a bit before, this one. Here. So let me repeat this question again. When to use CloudFormation stack as a composition, and when to use cross-stack references with import and export. The idea here is related to the life cycle of the stacks. When you want the child, the referenced or child stacks to be deleted or updated when the master one is updated or deleted, this would be nested stacks. So this would be CloudFormation stacks within stacks within stacks. And when you delete one or you update one, they cascade these operations and they happens to all the nested stacks. When you have import and export, they can live independently. I can export my topic, and then I can create many other stacks or delete many other stacks that reference this one without having to worry about this life cycle, because they're completely independent. I hope this makes sense to everyone. We're going to use mostly cross-stack here, but it is important to understand the both mechanisms. Okay. Yeah, this is an official AWS channel. I hope you like it. Let us know if you guys want to see anything here. Again, we're doing this starting with the AWS framework, but this is just our starters for conversation. Anything you guys want, I would be very happy to cover around here. And let's go on and create this on CloudFormation. So this is a very, very simple template, and I will start doing this by hand so everybody sees. And this is a pattern that I want to create with you guys. I'm going to show you how it's done on the console, and then we're going to automate it away so you don't have to. So within the console, we go to the CloudFormation page. Let me close all these other tabs to the right. And what we want now is create stack. And I will select the template to upload. It's here on that folder. Let's pick this cause of error topic, for example. And this will be my COE topic stack. You can name this anything you like. And within tags, I highly recommend everybody using tags to classify your environment. So you could say this is the owner of this is Julio. For example, the environment is, I don't know, prod, and the cost center is developers, for example. So when you create these tags, you can classify, and this really helps to figure out your bill, and you can classify it using this the resources, or even create security constraints. So you can, for example, know how much your service costs per environment, or per cost center, or per owner and environment. You can break down your bill to those tags. And for some services, you can even create security rules and IAM conditions to be more specific, referencing those tags, saying, for example, that somebody cannot shut down instances on prod environments, or developers can only access this environment from 9 to 5, or things like this. So permissions, I can give CloudFormation a role, and CloudFormation uses this role to create things on my behalf, things like this. But I'll just create this as is. It's going to be create in progress. So this is one, an important part of CloudFormation is that everything is created atomically. So you can see that in this one, I have a SNS queue, a SKS queue, and a SNS topic. So this is creating two resources, and it's going to either create both or none, so you don't end up with things that are partially or wrongly configured. So here we have the SQS queue that was created for us, and then SNS topic. If we go to those services, so I'm going to SNS and SQS, we're going to see the resources there. So we have that topic, and we have that queue. Okay, so this is how it works. For the bucket, so to generate a stack from an existing environment, there are a couple ways to do it. Let me show. One is called CloudFormer. So CloudFormer is this tool to create CloudFormation templates from existing resources, just as you mentioned. But beware that it is limited, so it won't go into your instances and see the things that you have installed there. So it may not replicate exactly, it won't clone your environment on the first play, but it is a good resource as a first step to get that. So this might be helpful. Oops. Sorry about that. Okay, so now let's go to some more automation. So this is what we did for the COE topic. Let's delete it and do it in a bit of a different way. I'm gonna delete this because we don't want to be doing things by hand every time, so let's automate this. And a very simple way to automate this is using shell scripts. So if we see on this folder, together with the template, I have a shell with the same name, and it just sets some variables, and the end goal here is calling this command AWS CloudFormation deploy, stating the stack name, and the template file, because that's just what we've done here, the same thing that we did on the template. I just want to, this is just generating a random name so we can do it over and over without collision. And this is pretty much it. So if you don't know this AWS command line tools, check it out on AWS Amazon CLI or awsamazon.com/CLI, and you will find the CLI tools that you can use on Windows, on Linux, on Mac to call all the things that are doable on the console. You can automate on the CLI. So for example, on EC2, that's more familiar to everybody, you can run instances, for example. So it would be the same thing as doing it by hand or by CloudFormation, but you can do it on the CLI. And CloudFormation has this deploy command, just like the other commands such as delete stack or create stack or update stack. The deploy command is the upsert. So you could just, it will, if the template does not exist, if the stack does not exist, it will create. If there is no, if there is already a stack, it will update the stack of the same name. So you don't need to do this logic within your shell. You can just call AWS CloudFormation deploy and let it handle everything. So topics are very similar to Rabbit MQ or other MQ's topics in the sense that they will ship messages through multiple destinations. The one thing to keep in mind is that Rabbit MQ or other MQ topics are pull style. They just sit there waiting for you to pull messages from it. And SNS is a push style notification. So the moment your message hits SNS, it will trigger all subscriptions. So it will trigger email, it will trigger if it is an email subscription, or it will send the HTTP request if it is an HTTP subscription, or your SNS message will not be stored in the topic as it would in a regular MQ. For that, we need SQS. And this is why there is a queue in this template. So if we look here, our topic already has a subscription that is sending messages to the queue that was created before. So this get attribute ARN of the queue will make this reference to the ARN attribute of the COE queue and using the protocol SQS because it's an SQS queue. So when we create this template, the topic will already have the queue subscribed. That depends. Some message queue solutions have durable topics, so that depends on the MQ that we're talking about. And because if you set it to durable, it needs to store messages to future subscribers that may be offline. So it depends on your queue or topic configuration. But the one thing to understand, and this is totally different from JMS or other MQs, it's just, you can even use as a regular queue with software like Camel, Apache Camel, and things like this, but it is a bit different. Okay, no problem, no problem. That's truly important. Thanks for asking. And so let's do this automatically now. If I got it correctly, we can just run this script, and you can see that stack name is a stack ID with a timestamp. Stack ID is a string, timestamp is the regular timestamp, and the other two variables are just for referencing this template file correctly, and this should do the exact same thing that we just did by hand. I just need to set up my terminal, and let me bring one here. Oops. And which is shared resources. And before we create, we just need to AWS configure, call AWS configure to set our credentials. And I can do it. I already have one by default, but it will ask for that key. Let's see where I saved that one. When we created this user just before. We could have created that user by CloudFormation as well, but I thought it would make more sense to show you guys step by step first, especially for beginners. So here is the key. Now for the secret key, I'm going to do this in a separate screen. So, oops, there it was. I'll have to change it afterwards, but you can use it for now. So I'll go with default for this. And right now, if we call AWS, for example, as EC2 describe regions, this should work. So here we have this command showed to us all the regions from AWS. And the same way we could call any command. And let's call that script. And just to show you guys again, it's just a simple the COE topic. So this is just could be a one-liner. I'm just saving it here so everybody can share and use the same idea. And here we go. So if we look at the console, you will see the same thing, because the whole idea is that the console, the CLI, the SDKs, they are just different clients to the same web services. So everything will be happening here. By default, it uses US East 1, so it's on a different region, but here it is, the very same topic. Okay, great. So now we need a bucket to store our config files and Lambda functions and things like this. And the code bucket have a little trick here. So it's pretty much the same, but it shows a bit of a different thing. That's this query thing. So if we take this command and try to call this describe stacks, you're gonna see exactly what I mean here. Let me pick the COE topic shell again. And this is a very important mechanism to take values out of CloudFormation and into shell scripts. So let me just set these variables outside the template so you can see step by step what's going on. So right now we have the same variables, and I'll call this command that's describe stacks. So with this, we should have the, and it could find the, oh, it's because this is a new stack name. So let me pick the same stack name that I had before. It generated the new one with the variable assignment. So here it is. Let me try to get it all in a single screen, just a bit smaller. And again, when we do describe stacks like this, you can see that it returns a list of all my stacks. If I hadn't sent a parameter, as I specify the stack name, it will show only one stack. And we can use CLI Queries to get part of this. For example, if I had, let me break this like this and add a query that says I need the I don't want everything. I want just from the stacks array, I want the first element, and that would be 0th. And now I have only the element. See that I don't have anymore the stacks array. And from this, I only want the, let's say this outputs array. So I can have dot outputs here, and I can filter. Okay, so you see I can dig into my response, my JSON response, and query for specific things. For example, in this case, I want the output value. I don't know. So you can go. This is this is outputs 0 again. So this is a query language that has all sorts of query mechanisms that you can use to fetch information from and out of CloudFormation, even after things are done. So that's what this is just a small hack, perhaps a very overly explained hack, but here's what it does. Let's get step by step those variables to create the bucket for our Lambda functions code, because we're not doing this by hand. We're storing that on S3 buckets. So this is the initial setup. We can see the stack name and echo stack name, for example. It's all reflecting that. All right. And now we can do the CloudFormation deploy. And this is going to create our bucket. If we can look at the console, and we're going to see this very same thing. Okay. So right now, my friend Galloway, we are creating the shared resources to automate security verifications. So this COE topic stands for cause of error, and everything that we consider a security exception, such as someone logging in as root, that should never happen, is going to be notified to this topic. To do this, we need to run functions, we need to run some code, and this code is going to be stored on this code bucket. So this is what we are doing. We are building our log processing stack step by step and making sure it's all correct and referenceable because we are going to build more layers on top of this. So we should have both complete, and using the same technique, you can see that this command will get me the name of the bucket. And this is going to be important later on. So I want to make just one more detail. See that this is output text, because the default output is JSON. So let's go back to this command here before. The describes text is all JSON, but if you guys want, this can be text. Just say output equals text, and it will come as lines of text, and table it will show as it will print as a table. Okay, that's better. So it may be more convenient for a given task. For setting environment variables, we want just to get the text and assign that to this code bucket variable. So now we have our code bucket name from CloudFormation inside my shell environment variable. So this is it would be, if you're not doing shell scripts, it may not make much sense, but for testing and replicating things, it may be good to write shell scripts so your peers don't have to. And this is a way to get those values into your script. And perhaps it's even a good idea to export so that everybody gets it. Every subshell gets it. So this is it. Now we can move on to the next part, and that's the audit trail. So here, let's see all resources that this creates. So the first thing, an audit bucket. So every audit log, every action taken by any user in your account will go into this bucket. This bucket will have a bucket policy stating that under this bucket, I'm going to allow the CloudTrail service to get the bucket ACLs that it needs to verify if they're correct. And I'm going to also allow CloudTrail to put objects just inside this directory composed of the bucket ARN, the logs, static name, my account ID, and anything. So here I'm just restricting under which resources CloudWatch is allowed to put objects. So this just showing you guys how you can compose things within CloudFormation. And every time you see an exclamation mark, this is a CloudFormation function, an intrinsic function. And Galloway, we're just starting. So this is if you catch from here, you surely will get everything, and you are more than welcome to review. But every day is a different topic here. Okay, so this will join the attribute with the bucket ARN, with the strings AWS logs, with my account ID, with the string star. So this is just concatenating strings so I can authorize on specific values, nothing more than that. A very important part is creating this logs group. So AWS logs is AWS CloudFormation. Hey, Slayer Darth. Yeah, I'm not Randall. Randall, I have a better foot than him. Randall is Great peer and doing all kinds of coding here, but we are a lot of evangelists showing all sorts of different cool stuffs here for you guys. And other than the log group, I create an IAM role saying that CloudTrail is allowed to create log stream and put log events into this log group. So I'm just saying that I have a code bucket for my audit logs, and I also have a log group. So I'm shipping my logs two ways. You don't need to. You can use just one or the other. When to use one, when to use others. If you're using something else to process your logs, such as ELK, Elasticsearch, Logstash, Kibana, or Logly, or Splunk, or Sumo Logic, or Logly, any log solution, it may be more convenient to use the S3 aspect and ship logs to your favorite solution from there. If you use CloudWatch Logs, that I highly recommend, it's a native AWS service for handling logs, then you can just use AWS log groups, or you can keep both, because you have better control of your retention policies on S3. For example, you can say that after 1 year, your audit logs go to Glacier, and after 10 years, they automatically expire, and you don't have the same amount of control in CloudWatch Logs. But CloudWatch Logs is easier to react to those logs live, and it can directly invoke Lambda functions for you. So I'm currently based in everywhere in the world. Every chapter on this was done in a different city. I'm from Brazil, talking from Madrid right now, but every week will be a different place. And yeah, cool. Nice to see you guys here. We are automating security. I'm showing how CloudWatch logs can be implemented and triggering Lambda functions to verify that nobody logs in as root in our account. So that's what we are doing today, preventing root logins. With this policy done, we can create a cloud trail finally. So this is the final audit trail. And again, this is how you reference. When you just want to reference one other CloudFormation object or resource, you use ref to make a reference. When you want an attribute of the resource, such as the ARN, the Amazon resource name of the resource, you use the get at functions. How do you know? How do I know if I need get at or ref? Always check. They are native to CloudFormation. CloudFormation will interpret this exclamation functions when it parses your template. So just again on the CloudFormation page, for example on CloudTrail, always check these return values. The return value section of every CloudFormation type will show you what it returns when you call ref and what is supported when you call get attribute. For example, this will allow you to fetch the ARN, the SNS topic, and other properties. So this is how you know what to reference here. And it is logging and is exported as log group. So now we can just run this script and see if it creates our CloudWatch trail. Oh, it's on a different bucket. So this is this. And I'm making this separate in different shell files and templates, so it gets easier for you guys if anybody wants to do something similar. It should be just a matter of setting credentials and executing the same scripts. Awesome. And we have all the next Twitch sessions, Calderon. They are on the page. So there's always check on AWS Amazon.com/Twitch. We have a Twitch page there, and we have live coding is what you guys are watching now. So this is done by me, Randall, and Abby primarily. So this is what's currently going on, and you have an archive of episodes as well. But we have other shows, the Maker Studio, the Game Day Essentials, the Tech Bites, and some special events. And keep an eye on schedule. We always have this. I will be here throughout the year talking about how to implement well-architected step by step. So we have a rollback in our audit trail. Let's see what happened here. So, see that my user is not authorized to perform this task. Remember that my user is not allowed to create IAM resources. So we may need to change that. So let's delete this stack and go back to the root account. It turns out that my admin group is too restricted. If we see the policy, it does not allow IAM actions. So this was too restrictive. I'm going to remove this power user and attach, let's grant admin access for now. And then you can, it's never going to be simple to define what administrators can do or cannot do, but now that it has an admin policy, we can try it again. And now it should work. And yeah, so using for those of you who don't know Terraform, it is a tool by HashiCorp, I believe. And it's a very interesting comparison and totally different thing from CloudFormation, a different implementation, but with the same idea of declaring infrastructure as code. It has more features in one sense, and as every other tool, it's got its good parts and bad parts, and I'll leave it up to you guys by now. But today we're talking about CloudFormation. But if you want, for example, a generic CloudFormation, for example, I wish that CloudFormation ran on my own computer. So if you want your own CloudFormation thing, then perhaps you should really take a look at Terraform. If all you need is AWS and creating AWS resources, CloudFormation may be a better way, but that's completely up to you guys. I'm not very much of an expert on Terraform, so this is pretty much what I can say about it. So let's see what's going on here. Incorrect S3 bucket policy. It seems that bucket policy I created is not very right for this bucket, meaning that it's complaining about this one. This bucket policy for this that contains the ARN and the logs for the CloudTrail. It should reference the region, the account ID, the log group, and perhaps this is /star. Okay, I see.